and welcome back to another video. So today we're going to be solving the LeetCode question, longest consecutive sequence. Okay, so in this question we have a unsorted array of integers called nums. The goal is to return the length of the longest consecutive element sequence. Okay, and they want us to do this in big O of n time. Okay, so over here we have nums. It's 100, 4, 200, 1, 3, and 2. So the longest consecutive list of elements we have are 1, 2, 3, and 4. Okay? And remember that nums does not have to be sorted. So let's just first look at what our basic, most initial solution could be. So the simplest solution would be to first sort this array of numbers. And when you sort it, you would get 1, 2, 3, 4, 100, 200. And what you do is you keep checking if the next number is the current number plus 1. And if it is, that means that the length of the sequence is going to be greater by 1. That's it, okay? And you do that for all the possible values, and you see which one has the largest length. That is what you return. Now, the problem with that is we first need to sort it, which is n log n, and then we have to go over all the numbers, which is an additional n. So n log n plus n is going to be the time complexity. So let's actually come up with a solution which does it in linear time, okay? So let's just look at this very basic example, 2, 1, and 3, okay? So what could we do? So let's say we start off with the number 2, okay? The first thing we can do is we want a consecutive series, okay? And what that essentially means is one of two things. So 2 can be part of a consecutive series, it could be the starting of a consecutive series, or it could be the ending. Now, if it's the starting, then every number after it is going to be greater than 2. Now, if it's the ending, every number before it is going to be less than 2. Pretty straightforward. And if it's in between, we're going to have both cases. So essentially what we're going to do is we're going to look at both of them, right? So for the number 2, we're going to check if we have the value that comes before it. If we have the value that comes before it, and if we have the value that comes after it. So we're going to do two things, okay? Well, obviously later on we're going to simplify this, but for now, this is the basic idea. So at 2, right? So now what is one value less than it? So 2 minus 1 essentially is equal to 1. 2 plus 1 is equal to, 3. So over here, essentially what we're doing is, so we have this, and now what we're checking is, we have the number 1 and we have the number 3. And now we need to see if both of these numbers actually exist in the given list of numbers, okay? So over here, do we have the number 1? Well, we do. And we also have the number 3. So this means that so far we do have a consecutive sequence, okay? And let's just continue. So now we have the number 1. So do we have 1 before that? Well, we don't have 0. And now now we're not going to do plus 1, right? Because we're only going to go in one direction. Cool. So far, so before everything less than 2, we have one number, which is this. Cool. Okay. And now we look at everything greater than 2. So we have 3. Now let's also look at 3 plus 1, which is 4. That doesn't exist. So that's going to be it. So this is going to be one of our sequences with a length of 3. So let's write that in a circle. Cool. Let me just close this. Okay. So now let's just continue. The next number is 1. So we do the same thing. We check for the number less than 1. So do we have 0? And we also check for the number greater than 1, which is 2. Now in this case, do we have 0? We don't have 0 in this list of numbers. But do we have the number 2? We do. Okay. So now again with 2, we check for the next number. So do we have the next number, which is 3? Well, we do, right? We have 2. We also have 3 over here. Now we look at the next number, which is 4, but we do not have 4. So in this case, again, we have the same sequence with a length of 3. Now this is something I want you to notice, which is we're going to do this for each and every number, and there's going to be a lot of overlap, right? So we found the sequence with 2, with 1, 2, 3. That's the same sequence, right? But we started at 1. That's it. Now we're going to do the same thing with 3. So at 3, let's look at the number less than 3 and greater than 3. So less than 3, we have 2. Greater than 3, we have 4. Does 4 exist? It does not, but 2 does. So we move on, right? So let's take 1 less than 2, which is 1. Does 1 exist? It does. Now we take 1 less than 1, which is 0, which does not exist. So over here, we come up with the same sequence again, 1, 2, 3. That's it, right? And this also has a length of 3. So this is one thing that we should kind of notice, that when we're looking at both directions, right, the plus direction and the minus direction, we are going to end up having overlap. So let's try to minimize this overlap. And one very simple thing we can do is we can only look at one direction. So let's just say we only look at all the numbers less than it. Now, why does this make sense? So let's say at 2, I don't look at 3. So right now, what does the sequence come up to? Well, right now, based on this, my sequence length is just 2, because I'm looking at 2 and I'm only looking at the numbers less than it, which is the number 1. 1 exists, but the number 0 does not exist. So I have a length of 2. But now in this case, I don't get the entire sequence, but that is fine because, so now let's say I go on to 1 again. Okay, so right now I'm at 1 and 0 does not exist. So remember, we're only looking at the numbers less than it. So 1 minus 1 is 0 and 0 does not exist. So in this case, the sequence length is just going to be 1, the number 1 itself. That's it. So now we go to the number 3. So remember, 3 is the largest number in this sequence essentially. So at 3, you look at the number less than it, which is 2, and 2 exists, and the number less than 2 is 1, which also exists, and then we have less than that 0, doesn't exist. So here we get the entire sequence. We get the sequence of length 3. Okay? So essentially my point here is we do not need to look at both directions. So at each number, what we do is we look at the number less than it, and we check if that number is in our sequence. Okay? So at the number 2, we check for the number before it, which is 1. It's there. So now we check for the number before 1, which is 0, which is not there. So we do this for each and every number. And essentially at the ending, you're going to get the length of the largest sequence. And especially in this case, when you have something like this, 2, 1, 3, right? If you directly just go to the largest number, you're going to get the answer the fastest. That's it, okay? So that is how we're going to simplify the solution. So let's see what this looks like in code. Okay, so one of the things that we're doing over here is we're checking if a certain number exists in the list. So a very faster way to do it is to convert it into a set. So if we have the set of numbers, the lookup time is just going to be O of 1, right? But if you were using the list itself, the lookup time would be big O of n, okay? So we're just going to use the set, and now we're just going to iterate through all of the numbers, okay? And over here, we'll also keep track of our result, which in the beginning is just going to be 1, okay? And over here, we check if the number, so we'll have a temporary result as well, temp_res is equal to 1. Okay, so we check if the number minus 1, so the previous number, is inside of our set. So if num minus 1 in S, okay? And in that case, that means we have the previous number. So now what we do is we have to check if num minus 2 is in the set, then we check if num minus 3 is in the set, and we do so until we reach the ending, okay? So what we're going to do, a simpler way to write this, we're going to have a variable called current num, and that is just going to be num minus 1, and we're directly going to check if current num is in S. So current underscore num in S. Now, if this is the case, what we're going to do is we're going to increase our temporary result by 1. And another thing that's going to happen is we're going to change the current num, right? So first it was num minus 1. Now it's going to be num minus 2, num minus 3, and so on. And the way we do that is we just take the current num, and we're just going to subtract it by 1. We just decrement it. That's it. So now we need to keep this in some sort of loop, okay? And a simple thing we can do is we can just keep it in a while loop. So while current num in S, that's it. And once we have this, what we're going to do is we're going to compare it to our original result. And we're going to take the maximum of the current result and what we currently just found, which is temp_res. Okay, and that's it. So at the ending of this, we would have gone through all the possible sequences, and we're just going to return whatever the largest one is. So let's submit this. Okay, so we have a special case over here where nums doesn't exist. So a simple fix for that is if we just put result is equal to 0. All right, so while the solution is correct, it is going to give us a TLE. And the reason for that is very simple, right? So I'll just go back to this original example we had, right? Which is we have sequence 213, and what we're doing is we're looking at all the sequence at all its different points, right? We're looking at when we just have the number 1, that's going to be the smallest one, right? We're also looking at the case when we have just the number 2, right? So this is in the middle, but essentially all we want to do is we only want to look at the condition where I have the largest number possible, right? And is there a way I could do that? And the answer is yes, there is. So essentially what we're going to do is very straightforward, right? We don't care about the number 2, we don't care about the number 1, we only care about the largest number in a sequence. And the way we're going to do that is while we're iterating through these numbers, we're going to, I'm going to check if the next number, which is 3, exists. At the number 1, I'm going to check if the next number, which is 2, exists. And finally, at the number 3, I'm going to check if the next number 4 exists. Now, what exactly is this doing? So essentially over here, the number 2, right? Because the next number 3 exists, that means that 2 is not the largest number in that sequence. Okay? So similarly, I have the number 1. So at the number 1, okay, essentially over here, I have the number 2, which is the next number. That means, again, 1 is not the largest, right? Not the largest in the sequence. So we are not going to explore that. But for the number 3, the next number is 4, and 4 does not exist. So that means that 3 is the largest number, and I'm only going to check the length of its subsequence. Now, just for the sake of it, say I had the number 4. Now, in this case, since 4 exists, I would not check this, but instead I would check the number 4. But now there's another thing I want you to look at, which is, let's say I have the number 5. Okay, so this is slightly important. Let me just clean this up. So now essentially what's happening is, so I have the number 2, 1, and 3, and the next numbers, I'm just going to write them, so 3, 2, and 4. So now in this case, I would still check the number 3. And the reason for that is because 5 is not going to be part of the subsequence, okay? And that is the basic idea. Now when I go to 5, I'm still going to check it, right? 5, the next value is 6, and this is just going to have a length of 1. But the reason I'm checking it separately is because it is not part of this original subsequence. So this simple check is going to get rid of our TLE, and it's going to make the code a lot faster as well. Okay, so let's just check right over here. So what we're going to do, so if the current number, whatever it is, and we got to check if the next one, num plus 1 is in our set, okay? If num plus 1 is in S, then in that case, that means that, well, this is not the largest number. So we're going to check if it's not in the set, and only then are we going to perform this operation. So yeah, this should remove our TLE, and let's submit it. Cool, so as you can see, our submission was accepted. So thanks a lot for watching, guys, and do let me know if you have any questions.